Hey guys, hi again. Welcome back to another video on Lead Code Coding series. Today we're gonna solve our new problem, that is a maximum subarray, and you will learn algorithm, that is cadence algorithm. So let's first understand what is the problem statement of maximum subarray sum. So here we have given an integer array nums and we have to find the contiguous subarray which has the largest sum, and we have to return its sum. We already know that what is a subarray. It is a contiguous part of an array. So we're gonna just take by our example, let's understand what is the maximum sum of this subarray. So to understand this problem statement, just take a look of this array. So here of this array, what are the subarrays? So if you consider only the first element, this could be a single subarray, or maybe this one is a subarray. Also same way is -2 to -3 is a subarray, and same way up to 4. If we will not consider -2, that means we will start from other index. So 1 minus 3, same way 1 minus 3 4, same way it's 1 minus 3 minus of 1 up to 4 is a subarray. Okay, so here you can see that what are the subarrays. Also if you only consider -3, so from that -3 itself, then after -3 4, and then you can say that -3 -4 -1, and -3 plus 4 -1 and 2 up to 4. So these are the subarrays. Same way we're going to consider for each and every element. Okay, so here you can see the total number of subarrays, and what we have to do, we have to find the subarrays which has the maximum sum. Actually this is our problem statement. Okay, the maximum subarray sum. So for this array subarray, this is -2, and when we add -2 and 1, it gives 1. So for this subarray, from -2 to 1, the sum is 1. Same way, suppose we add -3, it basically gives us minus of 4. Okay, that is the subarray sum. So in this problem, we have to find the maximum subarray sum. Okay, so here you can see that this subarray, when we consider from 4 minus 1 to 1. Okay, so this is basically the maximum sum subarray. Why? Because when you add it, it gives you 6. Okay, but the remaining subarrays sum are lesser than this value. So this is maximum subarray sum. Now, how can we solve this problem? So in this problem, 6 is the output. Okay, you can see here also 4 minus 2 and 1. 2 has the largest sum, 6. Okay, of if you consider all the other subarrays, suppose 1 minus 3 4, so it is lesser than 6. That means it's 2. When we consider 2 1 minus 5 or 4, it's also lesser than 6. Okay, so how we know that which subarray has maximum sum? So to solve this problem, we have uh, we have certain algorithms. Okay, so first of all, what we actually see here, we can get all the subarrays. Okay, and also we have to find the sum. So the basic solution of this problem, that is the brute force algorithm, is that we're gonna find each and every subarrays. Okay, and we're gonna sum that subarray and compare it which is maximum. And if you use a prefix sum technique, so where we can easily get the maximum subarray in order of n square. Okay, in order of n square. So here using previous idea, the time complexity is order of n square, but we will solve this problem is order of n time. Okay, so how can we solve this problem in order of n time? Simply, we're gonna use the same idea. Okay, and here the cadence algorithms comes. So understand what actually did we in a previous method or previous way. We can say that in the previous solution we basically check for every subarrays for each index. Okay, so the time complexity was order of n square, and we use the idea. So here we actually do the same, but we avoid all other the subarrays. Right now, understand how can we avoid that. Suppose you are at this index, okay, at index number 2, and the value is minus of 3. So when you reach at this index, so what are the sub arrays basically? So it is either minus 3, okay, or so it is either minus 3, and or the it is 1 minus of 3, or we can say that minus 2 1 minus of 3. So these are the sub arrays, and we have to know that which subarrays sum is maximum, and we say that sum is local maximum. So here you can easily see that 1 minus 3 is the maximum local maximum subarray. Okay, so for this index we already calculated 1 minus of 3, and we avoid other subarrays. Okay, think about if you start from the very beginning, so you have only option like you have minus 2, but when you reach at this index you have two options, either minus 2 1 or minus sorry or 1. So there also we have to find which is local maximum, so it is basically 1. So so when you reach at the index minus 3, you will not check for the this like this index. Why? Because we already calculated local maximum. The idea is simple that we simply calculate local maximum. So here the idea is simple that we calculated first local maximum. Local maximum is simply for every index we already calculated the maximum subarray at that index. That is our local maximum. Okay, when we suppose reach at this index for minus 2, there is only one element, so the maximum subarray is minus of 2 itself. But when you reach at this index at the second index, sorry, it's index value 1, so here the maximum is 1. Okay, so right now local maximum is 1. So when you go like the next index, so local maximum is 1 minus of 3, that is minus of 2. Okay, so every time we calculate what we calculate basically local maximum. The our first thing is that there are two phases. You can say that there are two phases in this problem like algorithm. First we calculate local maximum. After that, finding every local maximum, we will find our global maximum. And every time we find local maximum, and how we find local maximum, that is another thing. And first understand there are two ways. We first find local maximum. Okay, so for every index we find our maximum subarray, and from that range of local maximum we will find which subarray sum is maximum. Okay, and just write that maximum local max, you can say that maximum local max. Okay, so among those local maximum, the maximum local max is our global max, and that is our answer. So this is basically the first layer, and this is the second layer. There are two phases in this algorithm. And now the question arises, like how can we calculate this local maximum? That is very good question. Okay, so in the previous example, we can say that in the previous solution, generally we have to compare with all other subarrays. Okay, so when you reach at this index minus 3, so simply what are the possible subarrays? It is minus 3 1 comma minus 3 minus 2 1 comma minus of 3, and we have to sum all the subarrays and we have to check which is maximum. But here we have a concept of this local maximum, so why we will not check for all the subarrays. So simply we will avoid first this subarrays because we already calculated the local maximum as this index as 1. So if it is, suppose this value was plus 2, that means local maximum is 2 and 1. Like the sum is 3 of local maximum is 3, and what are the sub arrays? So the from index beginning to 1 at this index. So we will only go for that. So simply what we actually do, we actually so what we actually do, we every time add the value with local maximum. Okay, we every time add the value with local maximum. Maybe that value when we add with local maximum is our like new local maximum, and maybe the new value, that is nums of I, the current value is itself a local maximum. So this is also an option. Okay, so uh, either we calculated the sorry, yeah. Okay, so here nums I, sorry, num I or nums I, so that is either the current value at which index we are right now. Okay, either that value is maximum with local maximum plus the current value, because maybe that is a negative value. So we have to find which is maximum among these two value. Okay, so local maximum plus num size, we every time what we actually do, we will not go for all the other subarrays. We simply add the value with local maximum, and we will check if that local maximum is greater than the current value. Like this sum is greater than current value, so if that sum is greater than this current value, that means the new local maximum, we gonna reach that. And every time when we find that local maximum, we will compare with this global maximum, and there we will just store the maximum value at the global maximum. And also this is the process, but you're gonna ask me that why every time the local maximum, when we're gonna add the local maximum with nums of I is the maximum than all other the previous sub arrays. So here simply think, okay, so here simply think, since we have to find the like sub arrays are like contiguous elements. Okay, and what we have to do, either suppose you are at like this index 4. So either the previous sum, like you can ask me that here in this situation 4 is maximum with the previous like sum. So 4 is our local maximum here. Okay, so we will not go for like for all other sub arrays. So here we will consider from this. Okay, so again when we reach at this index, we will only go for like this index. We will not check for all other the sub arrays. But for 4 local maximum was like minus 2, and we're gonna just add 4 with that value. Okay, so a local maximum itself is a contiguous subarray. Either either it is the just previous value, because for minus 1 it is just their previous value 4. Okay, we simply add minus 1 with 4, so it basically gives 3 here, the local maximum. Or it is the previous any contiguous subarray. So for minus 1, what are the possible subarrays? So it's simply minus 1, it is simply 4 minus 1, and minus 3 4 minus 1 1 minus 3 4 minus 1 1 minus 2 1 minus 3 4 and minus 1. So these are the possible subarrays. So we already calculated among all those subarrays which is maximum, and it is obviously contiguous. Why? Because we every time go like forward, we left the previous value. If we're gonna like add that value, it becomes a lesser value. So we just left those values. So here for 1 and minus 3. Okay, so when we reach at this index 4, so that is local maximum, and this is also a contiguous subarray, so we don't need to add this minus 2. Okay, so for every index we simply, for making that is a contiguous for subarray, we simply check with their previous subarrays. So there are a lot of subarrays for this index like value 2, for value 2, but here we will only check for local maximum. and the subarray who gives local maximum is already contiguous, okay, because we like build it from like with connect with every single elements. Okay, so every time we go forward, we just step one, like go step one. Okay, so here for 2 we only check which local maximum is greater than 1. So initially it was 3, so here for value 2 the local maximum is simply 3, it was 3. So we simply add 3 with 2, it gives 5, and the current value is 2. So we actually know that this is 5. So this is our current local maximum. And what are the like sub arrays? So it is simply we are here. Okay, so this we are here. I'm just using another pen to make it more clear. So we are here. Okay, so we did not left because initially local maximum was 4, so we add minus 1 with that. Okay, we no any other values has come again where we left our previous local maximum index. So this was the index, initial index for this current local maximum. Okay, and in that local maximum we simply add the new value. So here for 2 we simply check with value 2, or either we're gonna add 2 with this previous local maximum. It was 3, and for this 3 what are the sub arrays? It was 4 minus 1. Okay, it was 4 minus 1, so we simply go for this there. And right now we actually calculated the value 5 for these two. So the current sub arrays are 4 minus 1 and 2, and we reach at this index. So simply here we are going to add 1 with our previous local maximum, that is this sub arrays 4 minus 1 comma 2. Okay, so here it is simply 6, it is simply 6, and we compare 6 with value 1. So which is higher value? Like obviously 6 is higher, so our current local maximum is 6. Okay, so here we reach at here, this is our local maximum. Also every time when we calculate the local maximum we will find which is our global maximum. So among is those local maximum we find that this 6 is again, this 6 is still maximum value, so we already stored that value in global maximum value. Okay, and after that when we reach at this index like this minus 5, so here we have two options, either minus 5 is greater than all other values when we gonna add this. So for minus 5 what are the local maximum sub arrays? Simply we're gonna check for only one sub array, we will not go for these sub arrays for minus 5 like are we gonna add this one or not. So here for minus 5 we will check like local maximum sub arrays sum, previous sub array sum, it was 6, we simply add minus 5 with 6, it gives 1, and we will compare 1 with minus 5, which is higher, it is 1, simply 1. So you can see that now the local maximum value is like decreasing. Okay, but for the we have right now the sub arrays is this, but we already calculated the global maximum, it was 6. So we will not update the global maximum because the new value is lesser than 6. Again we reach at the next index and it is 4 right now. So either we add 1 with 4 or we just compare with 4. So when we add value 1 with 4, so it is simply 5, and our new value is 4. We compare 5 with 1, 4, which is maximum. Obviously 5 is maximum. Okay, so the new local maximum is 5, and we simply compare it with global maximum, and we find that this 5 is lesser than 6. So here we already calculated this 6 is our global maximum, the maximum sub-array sum. So the idea is simple. We simply avoid all other sub arrays. Okay, and we will only focus on like locals maximum sub arrays. So for this, we actually calculated for this sub arrays. Okay, so calculating global maximum is another thing. So for that global maximum, we will only consider at this index. Like for this sub arrays gives our maximum local maximum. Okay, 4 minus 2 comma 1. Okay, 4 comma minus 1, and this is our answer, and 6 is our global maximum. But we actually update the local maximum when we left the local maximum sub array. Suppose here when we calculated for this 4, So initially local maximum subarray was 1 comma minus 3, this was, and when we left this subarray, uh, like here 4 is maximum than this sum. Okay, like minus 2 plus 4, it is simply 2. So there the current value, like you are like this border, sorry, 1 minute. So you are at this border. Yeah, you are at this border. So here you want to build a subarray. Subarray is contiguous. So either you will consider this element or the previous subarrays. Okay, you have to choose like any two, any one subarray. So here this value like 1 minus 3 plus 4 like is this subarray. So for there are only two subarrays, the local maximum plus 4 and 4 itself, because when you go forward we will only consider the last value or the previous subarray. Okay, so here we find that 4 is maximum than the this subarray 1 minus 3 comma 4. So why we left this subarray, we will not go forward with this subarray, and also we calculated the local maximum, and here the new subarray starts from this index. Okay, and we go forward, and when we left that index, when we reach at say same situation where the current value is maximum than the all the previous uh, like subarray local maximum subarray. Okay, so this is basically our cadence algorithm. Hope you understand the algorithms. If you don't understand, then please you can like watch it, and also after when we explain the like code of this algorithm of this problem, you will understand this better. Okay, so let's understand our code. Same things. So here this sum variable is simply our local maximum variable. You can just write local maximum, and this maximum value is basically the global maximum value. Now here what we actually do here, okay, so we simply iterate a for loop from where? From index 1, because if the value is simple, string 3, at like only one element, that means itself a maximum subarray. Also for the first element we don't need to write the range, it is itself a maximum subarray. So here simply we're gonna start a for loop with the value 1, and the value I is less than nums dot length and I plus plus. So simply we iterate a for loop from the nums array with the index value from the index value 1. And right now here you know that this sum is nothing but it's the local, okay, local maximum subarray sum, and this max is a global subarray maximum sum. So here, what how for the global maximum, that is this max value is already greater than this sum value, that is a local maximum, and that means that is our answer, and we will simply return. If suppose sum is maximum, that local we have just calculated. Suppose we have just calculated some value, and this value that is a local maximum is now greater than the previous global maximum, the max value. That means we simply just compare it, and with gonna put the value, okay, which is maximum at the global variable. Also thanks for watching, and if you like the video on lead code coding series, so please do subscribe to the channel.